Hello guys, welcome to Learn with Venki. Today I will show you how to find bending stress as well as how to generate shear force diagram and bending moment diagram using HyperMesh software. For this, have a small problem, a cantilever beam having an demo plan and point rod at the end having a cross section 10 mm into 10 mm. I calculated analytically I am getting bending stress around 600 megapascals, and you may come across these shear force diagrams. You can see for shear force we have a rectangle shape, and for bending moment we have a taper shape. So now we will see the results in HyperMesh and we will compare with these results. So now let's move on to HyperMesh. So now firstly HyperMesh is a very good software having a wide range of capabilities. So I request you to use HyperMesh software to improve your knowledge. So now for entering into the HyperMesh interface, first you should check whether the solver interface should be opti-stuck or not. Then you have to right click here model browser. If you don't find the model browser, you can select from view. Here right click and create material. First thing you need to do, you have to create a material, steel. Then card image should be matte one because it is an isotropic material. And after moving your cursor, you can see the values are coming automatically. If you want, you can use this, or you can enter a new values. So now I am confirming the first 4 values and I will close. So now the material has been created. So now for beam, we need a line because beam is a 1D element. So I will create a line here exactly on top here. So now the plane has been created. I will create a line, something like this. Then I will select this dimension option and I will give the dimension as 100 mm. Again, I will select this vertex and this origin and I will give 50. Now our line is created exactly at middle. Now press on escape. So the line has been created. Go to 1D and select beam sections, because for a beam we need a section. It should be standard, and this rod should be changed to bar, and the breadth and depth 10 and 10. If you want, you can change. In this problem we are having 10 mm to 10 mm cross section. So now the results are automatically came like moment of inertia around XYZ. So now the calculation is been done. So now close this one. After closing this one, we have to create a property. This should be beam. You can see beam L and beam. Select beam L because for beam should not get the stresses. If you select P beam L, you will get the stresses. Select the P beam L and assign the material steel, the beam section which we have created. Close this one. The line has been completed and we have given the section also. Now we need to mesh this one. Select this line mesh option and select this line and give element size as 3 mm and edit the element category. And give the element category is beam 1D and property which we has created now, and close this one. So now press on the tick mark and mesh has been completed. You can see the elements and nodes as kind. So now we have to go to analyze tab and we have to give the boundary condition. Select the leftmost end and press on tick mark and create. So now you can see the constraint has been created at the leftmost end. We have to create a point load at the rightmost end. Select this point load, click on tick mark, and here y direction should be 1, all direction should be 0. Then magnitude is 1000 Newton. Click on create. Now you can see load has been created at the end. After this, you should create a load step. Create load step and define analyze step as linear static. And this aspect should be auto. And again this one auto. Now you should check EL force. First you should check the output. Then you have to check EL force. So give here 2. And the format is output 2. And again here format is S3D, because you can use this in 2 formats. So now after this, should check the GP force. Should give same 2 value here. And the format is output 2. Again format is S3D. After this, you should select this GP strain. Give 2 again here. Give format as OP2. And this format as S3D. Again do same for GP stress. You give 2 here. And the format is OP2. And lastly, we'll give format for this S3D. So now the output we have given. So we are requesting software to give these outputs. So now check you have given everything or not. And close this window. So now all setup is completed. Now we have to click on analyze button. We have to give the name SFD and BMD diagram and click on save button and click on export button. So now that's what I will ask to run. Run this one. You can see the analysis has been completed. There is no errors. So if you want to see the results, click on results here. Start clicking on results. You will get this hyperview interface. So now you have to go to contour plot and we have to select here one masses stress. Then you have to select here one masses max, and here you can see apply button down and click on this button. You can visualize these results. You can see the stress is at exactly at leftmost, and you can see there is no stress at the rightmost where we have applied the force, and where we have constant we are having more stress and 600 megapascals. We can check with here. You can see we are getting same 600 megapascals analytically. So now we have seen the stress. If you want, you can visualize displacement also. Select here displacement, and here in y direction, and again Click on apply button. So now we are getting 1.9, 1.92 in negative direction. Displacement you can visualize here. So now after visualizing the displacement and stresses, we'll move to shear force and bend moment diagram. So now we'll close this window and we will go to again HyperMesh window and here post processor, and we'll click on the results plus symbol import and we will select this one and we'll press on open. Now select this contour and select the component, this one, and click on the right button. So now the system has generated automatically some forces. If you go here, click on contour, you can visualize here. It has generated element force. If you want to change, you can change from here. Element moments, all those things it has been given. Now we need shear force and bending moment diagram. For this, you have to go to the bar plot. The page will appear here. Create beam section. Here element you have to select this one and we have to select this force, and here you can see force moment diagram in FZ and direction should be Y. If you want to visualize this one with more graphically, should give here the arrow length is 300 or 500 and should select this, uncheck this show values. So now we can visualize this shear force and bending moment diagram. So now I have shown shear force diagram. Now I will show the bending moment diagram. To click on the show values, you can visualize the shear force. At every point we are having 1000 newtons. So now I will show bending moment diagram. Here you have to select the MY in Y direction. So now you can visualize the bending moment diagram. If you want the forces, you should select this bar plot and you should select only F5 and show values. You can see the force set every end. It is showing. So now I have shown you how to generate shear force and bending moment diagrams in HyperMesh easily. So if you want my videos to come in your feed, you subscribe my channel and give a thumbs up. So I have made a playlist on ANSYS Workbench. If you want to see those videos, you can go to my profile and you can see the playlist ANSYS simulations, or else I will paste the link in the description. So thanks for watching the video. See you.